Hello, you're welcome. Today we have these two Fresnel's integrals. The integral from 0 to infinity of sine of x squared dx, that this is equal to the integral from 0 to infinity of the cosine of x squared dx. So in this video we're going to make use of the Mellin's transform. It's very nice. So let us recall that the Mellin transform for the cosine of x that this is equal to the integral, right, from 0 to infinity of x raised to the power of s minus 1. Oh, let me write that properly. So of x raised to the power of s minus 1, then multiply with the cosine of x dx, that this is equal to gamma of x, then multiply with the cosine of s pi over 2. Interesting, right? And then for the sine of x, then the Mellin transformation of the sine function is equal to the integral from 0 to infinity of x raised to the power of s minus 1 multiplied by the sine of x dx, and this is equal to gamma of s, then multiplied by the sine of s pi divided by 2. But how is this going to help us here? We have sine of x squared and cosine of x squared. So what do? So let's start with the following. We have the integral from 0 to infinity of the sine of x squared dx, and here also let's call this I sub 1 and here I sub 2. So I sub 2 is equal to the integral from 0 to infinity of the cosine of x squared dx. In both, let's do the following substitutions because we really need to have just x and not x squared. Okay, we're going to let x squared equals t. So for x, we get x is equal to square root of t. Now differentiate, we get dx is equal to the derivative of square root of t with respect to t is 1 over 2 root t, and then dt. So now our I sub 1 is going to be equal to the integral, our limit remains the same, right? Then we're going to have sine of t, then dx, which is equal to 1 over 2 root of t, and then dt. While our I sub 2 is going to be integral from 0 to infinity, we just have cos t, 1 by 2 root t, and then dt. So let's simplify a little bit. So here our I sub 1 is going to be, we have 1 over 2 outside, the integral from 0 to infinity. 1 over t is same as t raised to the power of negative 1 over 2. And then we have sine of t, and then dt. While our I sub 2 is going to be equal to 1 by 2, the integral from 0 to infinity. We still have t raised to the power of negative 1 over 2, cosine of t, and then dt. So from here, our I sub 1 is going to be equal to 1 by 2, the integral from 0 to infinity. So this is going to be t raised to the power, we must have something minus 1, which is 1 over 2 minus 1, and then sine of t, and then dt. While our I sub 2 is going to be equal to 1 over 2, the integral from 0 to infinity, then t raised to the power 1 over 2 minus 1, cos t, and then dt. Now, according to Mellin's transform, remember our I sub 1 according to Mellin transform, remember we have just 1 over 2, then we have gamma of s. In this case, our s is 1 over 2. Then multiply the cosine of s pi over 2. S is 1 over 2, so it's going to be pi by 4. And here I sub 2 is going to be equal to 1 by 2 gamma of 1 over 2. Then, oh, sorry, this is going to be sine. Oh, sorry for that. This is the sine function here. So we're going to have sine, and here we're going to have cosine of pi by 4. Now, why the two integrals are equal is because the sine of pi over 4 has the same value with the cosine of pi by 4. And at the same time, this is going to be 1 over 2. Am I getting it right? Yeah, multiply by the gamma of 1 over 2 is just square root of pi. Multiply with sine of pi by 4 is square root of pi, square root of 2 by 2, I mean. Is that square root of 2 by 2? Am I getting it? Yeah. So it's going to be, this is going to be square root of, am I getting this right? What the hell is wrong with me today? Okay, so let's relax and find out the truth. Okay, so here, this is going to be square root of pi, then multiply by, this is going to be square root of pi by 2. Did I get it right? Square root of 2 by 2. Oh, God. Forgive me, friends. So square root of 2 by 2. And here, I sub 2 is going to be 1 by 2, the same thing, square root of pi, and then square root of 2 by 2. Now, let's simplify. Square root of 2 by 2 is same as 1 over root 2, right? So our I will finally give us square root of pi divided by 2 root 2. While this one here will give us the same, square root of pi divided by 2 root 2, which we know 2 root 2 is same as square root of 8, right? So this is finally giving us I sub 1 is equal to I sub 2, and everything giving us the square root of pi by 8. Interesting. Oh my God, this is cool. Thank you for watching. Please stay tuned for the next video where we're going to evaluate the integral from negative infinity to positive infinity 1 divided by the secant of x squared plus 3x minus 5 then dx. Oh my God, this one is crazy. Thank you for watching. Please subscribe to my channel, also like, comment and share.